It's 2 hours UTC, and it's time again for Astronomy Daily Live. Hey, everybody! Hope everybody's doing well. Yeah, this is Lazy Cosmic. Lazy Cosmic today. I was going to live stream again outside. I was going to be doing some observing tonight again, and yeah, in the past hour or two, I've been thinking about it. It's going to be another beautiful dark night, and no wind. Perfect for astronomical observations. And here I am sitting inside. But yeah, I'm just. I got. I got data last night that I need to, sort of process and look at. Well, I need to reduce it, right? I need to calibrate it, and then I need to do the analysis of it and see where I stand with that. So, it was kind of a frustrating night. The telescope, this thing behind me, was not pointing very well. So I've got such a narrow field of view. My field of view, um, using the camera that I have, and this is one of the limitations of this camera, is that the CCD array is very small. So I can only look at a very small patch of the sky. It's 12 arc minutes wide and 8 high, and so that's less than a quarter of the size of the full moon, and it's just to the telescope does have the capacity to point that accurately, but for some reason last night it was just not cooperating at all. I was doing everything I could think of to uh, 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 figure it out, and nothing happened. I was just distracted by the chat. So, Bobby, my Discord is asking me for an invite link. You just joined. Okay. Uh, okay. Yeah. Uncle Bill is on it. So cool. Thank you very much, Uncle Bill. You are the man. Thank you much. So again, it's hydrogen hydroxide tonight, HOH. Got a fresh new batch just made. So yeah, it's tasting pretty good tonight. So yeah, it was I got I and I mean, I honestly, I can just sort of call this luck that fuzz in my head. Yeah, I don't think so. Um, just a little bit of luck that I did sort of stumble upon one of the binary stars um, that I wanted to do. So I did get a bunch of data on that one. So that's very cool. So I'm going to have to, as I said, I've got to run it through. I have to reduce it, I have to calibrate it, and then I have to do the analysis to see how it looks. So I did get some data last night, but it was mainly just a frustrating thing because my pointing, the tracking was actually really good, really nice last night. I could actually, I took 200. I think they were half-second exposures, um, and so that took a little while, and the tracking was good enough that I could actually walk away. Right, I could walk away. I could come into the house, I could, fiddle around a little bit. Of course, I didn't stay away too long because my work was outside, but but um, uh, uh, but then after that first one, it's like, okay, I should try to make sure my focus is okay. And so I I lost I lost the binary star that I was looking at. Sort of stumbled upon another star that I could focus with. So I spent, focus is really, really, really important. And so you know, stumbled on another star that I could, uh, make sure your focus was sort of optimal. I diddled around with that a little bit, and then moved on to binary star number two, which I never found. So yeah, I got to come up with a different way of doing that, and I think probably the best way is to actually put a finder scope on there with a little bit of an aperture and a little bit of magnification. So maybe like a you know a five by 20, anything really, other than what I've got on there now, which no, you can't see, but it's just a it's like a cheap Telrad. It just projects a little red spot into the sky at 1x. So yeah, it's sort of hard to see anything except for the visible stars, and of course the binary stars that I'm trying to look at are just beyond visibility, at least easy visibility in order to point the scope in the right place. Um, so yeah, I had to rely on the mount in order to point, and the pointing wasn't good enough to put my target anywhere in the field of view. Um, and even if I mean, I scanned around, right? I mean, what you do in that case, right, is you let the scope slew to wherever it's going to go, and then you sort of do a pattern like this, right? Pattern like that. So you sort of cover, a pretty large area. And I did that, and I still wasn't finding anything. So yeah, I knew that the moon was going to be rising around 10:30 local time. So it's like, okay, if I don't have anything going by 10:30, I'm going to call it, and that'll be that. And so yeah, that's how it goes. That's how it goes sometimes. So uh, so look, I'm going to get on my smartphone here to make sure that my live stream is live streaming. I can see the chat. Hope everybody's doing well. This is Astronomy Daily Live. This is just a fun, casual get together every single day at 2 hours UTC, um, where just a circle of friends get together, turn off the TV, we forget the news, and we think about the universe, and we think about how awesome all of that is. And yeah, this is for everyone too. This is for new people who don't um, know um, anything about astronomy at all and want to find out. They're curious. They have questions. Um, Bring them on. Bring them on. This is for I'm the amateur astronomer who is experienced and just wants to you know think and talk astronomy a little bit more. And it's for the pros as well. I like to talk it all levels. So yeah, hope you're all having a great time wherever you are. As I said, I was going to be doing some observing tonight, but I decided sort of last minute to wimp out and, you know, take it easy. Got some data from last night, so I've got to take a look at that, and then we'll go from there. So very cool. Um, I guess I watched Tony Darnell's Deep Astronomy uh, 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 production from yesterday. He posted a thing, um, a um, a video on YouTube where he posed the question, "What's the difference between an astronomer and an astrophysicist?" And his short answer was absolutely nothing at all. And I completely agree with that. Completely agree that in terms of I mean, if you want to talk about what is being done, um, yeah, being an astronomer, being a astrophysicist, same exact job, same exact job. Um, but then he elaborated. He elaborated, and what he basically came down to was is that um, people who sort of think highly of themselves and want to make themselves, you know, sound well. They want to impress their friends or they want to impress others. They will call themselves an astrophysicist because it for some reason our culture has decided that that sounds better. It sounds better uh, than being just a lowly um, astronomer. And yeah, I think that's I think that is correct. That is correct. There's a pretty big bias when it comes to science, and I have experienced it firsthand because my path has not been sort of the normal path. It's sort of the Thoreau path, the path that is trodden by the beat of a different drum, and yeah, that's how it's gone. I was actually on sort of the academic path for a while, but I knew I knew that it wasn't for me, but I really didn't know what other paths existed um, until I was basically dragged off of that path onto a new path. Um, yeah, I was offered a job, and it was one of those sort of, I guess, what you'd call opportunities of a lifetime, where it's like, okay, am I going to do this or am I going to do this? And both paths were uh, wide open and available, and but the path that I took seemed a little more appealing, and you know, uh, seemed to be more in line with uh, what I wanted to be doing, r- rather than going down the well-trodden path. I decided to take a path less taken, um, which made things a little bit more interesting. Um, definitely in terms of a livelihood, it's been much more challenging for sure. And the reason for that, and this is sort of the interesting thing, is that the people who hired me, um, uh, what it came down to is that they needed me. They needed my experience. They needed my knowledge. They needed my expertise, um, where they couldn't find it anywhere else, even within themselves, And um, most of the people that I with, really did not like the fact that I was on this other path, and all of them were on this path. Um, but there were a few who were, they had my back, and um, realized that what I brought to the table was of very high value, and so it's like you might not you know like the fact that he's doing what he's doing, but he's really good at it, so you have to keep him on, right? What was I going to say about that? There was yeah, it's I I was doing things that the PhDs couldn't do at all, and they didn't like that at all. So yeah, I've definitely experienced that kind of a bias, and yes, it has kept me back. It has kept me down. It's kept me out of new opportunities, um, which is something that needs to be dealt with at some point in the scientific community. Not everyone has to have uh, paperwork, right? Not everybody has to follow this one path in order to sort of be accepted. But as it is now, there are well, I know of at least one example of someone who is locked out of great opportunities because I don't have my papers, and it's I mean I deeply respect anyone's path that they take to you know um, get into a position to qualify for a certain kind of work. But to say that this person's path is valid and that person's path isn't valid, if what you get in the end is the same thing, um, yeah, there is definitely a bias there, and gotta say there's a prejudice there for sure. There's a prejudgment that goes on if you don't have your paperwork, and that uh, that's probably going to change. That's going to slowly change. But that's why people are encouraged to get a degree, because then you sort of that bias just doesn't show up at all. And but if you don't have that, then you are, and I have been, you know, treated um, pretty poorly. But I understand that it's a bias, so I don't have any kind of grudge or anything like that. I'm sort of calling it as it is, and it is a prejudice. It's a bias, and you just have to carry on, and I'm I'm completely happy, you know, trying to do my own thing, and you know, uh, not interested in getting paid a lot. Um, Money does not motivate me really in any way. If I can pay all my bills, then I'm free, right? So that's all that matters. And if if those demands weren't on me, then I wouldn't have any um, um, any interest um, in acquiring dollars at all, because it's like, what's the point? I don't need them, but unfortunately, I do. Right? I've got to pay the electric bill. I've got to, you got to pay for all these things because everybody wants dollars. So, so be it. So be it. But yeah, I think this is um, it's not a better path. It's not a worse path. It's just a different path. And as I say over and over and over again, and I will continue to say over and over and over again, if you're having a good time, if you're having fun, if you're feeling happy, see, happiness isn't a goal. Happiness is a feedback mechanism. So uh, if you're happy, then you're probably in your groove, right? And if you're not happy, then you're outside of your groove. But to have a goal of being happy, no. My goal is to be in the groove, because then uh, I'm naturally happy and having a blast. And yeah, for the most part, I am. I am for for sure. So what goes on Discord? At least at this point, Bobby, it's like a forum. It's like a place for participants to post things, have discussions, whatever. It's just another platform. Um, we can have audio on there too, and feel free to use that as well. I eventually want to um, sort of tie all this in. Need to get some a little bit more hefty computing power here. I actually have a second Linux box that might be able to handle like OBS and all that. I need to um, uh, take some time to check all that out. But Discord, yeah, is just another um, uh, platform for discussions and sharing and all of that. So yeah, feel free to get on there and look at the posts. I try to post on there at least a couple times a day. If I see an interesting paper or I've got one channel that I call Links to Awesome, and it's just anything I find that it's like, wow, that is very awesome. I'll post a link there, um, and then this 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 whole format here, uh, I'd like very much to tie into art as well, because art and science are are connected in a huge way. Um, I dare say that a lot of mathematics these days is more artistic than anything else, and it's awesome though. It's completely awesome. Um, and so yeah, I've got an art channel. Um, Anything space related, I've got a space channel. Yeah, any suggestions in terms of adding or removing channels, from my server, let me know, because you know, my thing here is that I just want to get better and better and better. So yeah, very cool. Let's see. Cheers. You know, we haven't done a object of the day in at least a couple of days, and I'm sort of wondering. I've got I now have three different kinds of objects of the day. I have a object of the day where I choose from the Messier list, which is 110 uh, non-stellar objects. Um, I have an object of the day where we choose an object from the NGC list, the new general catalog list. And those again are, for the most part, also non-stellar objects. And then I have an object of the day where I randomly choose a constellation, and we sort of look at the constellation and then find an object or two in there to just sort of look at. As I said, you know, this live stream is not educational. I'm not here, you know, to sit here and teach you things. You're all of you are fully capable of teaching yourself. I can sort of, you know, point things out and you know, exchange a little bit of knowledge I have, but I'm not here, you know, to teach or anything. So I mean, that's going to happen. That's going to happen, and it goes both ways, right? I mean, it's not just me teaching you. You folks are teaching me um, as well, because this is like a virtual porch, right? We're, you know, gathered together in our lounge chairs, right? Consuming our consumable of choice, whatever it may be, and um, we sit here and we share a passion, and that's it, and that's it. So you know, communication will happen, education will happen. But yeah, you know, let's talk about telescopes and art and space travel and you know, CCD cameras and binary stars and galaxies and whatever else. It's very, very free-form, very, very casual, and hopefully fun. Hopefully fun. So yeah, and um, Uncle Bill, I just went through the May events as they were shown on cloudynights.com. Cloudynights.com. It's a great, great, great site. Extremely active. Um, it's um, a um, amateur site, but very, very awesome. Extremely, extremely great. As I said, very, very active. So check them out. Cloudynights.com. Sign up there and check them out. Hearts of Space is coming up on Sunday, so don't forget Hearts of Space. Um, I haven't seen. They usually tweet what their next show is going to be, and let me look really quick here. Let's just see if I missed it. Maybe I did. Let me see if they've tweeted what this week's show is going to be called. They usually do themes. No, it's not up yet. Not up yet. They're so they'll probably post either tonight or tomorrow. So follow them on Twitter too. It's just called Hearts of Space, all one word, lowercase. So check them out for sure. Let's see. So how about if we just do a object of the day from the new general catalog? Oh, oh, before I forget, there's a launch tomorrow. Tomorrow. Now it's going to be at 11:05 UTC. That's when it's scheduled to go off. It's the Mars Insight mission. So at 11:05 UTC. Now you'll have to figure out what time that is wherever you are. Of course, it's going to be shown live. You know, the launch and all that. But I'm in southeastern Arizona. Okay, and Vandenberg is where it's being launched from. Now, Vandenberg is pretty far away from me, but that rocket's going to be going, pretty high up and then arcing. And I did learn today. I watched they had an hour and a half long um, uh, um, sort of press briefing uh, today or yesterday. I forget exactly when. And they showed a sort of a visibility map. And I didn't pay much attention to the visibility. What I was paying attention to was the path of the rocket. And it is going to be going south. So there's a possibility that I might be able to see it. So I'm going to get up 11:05 UTC. For me is I'm 7 hours behind that. So that's 4:05 a.m. local time tomorrow morning here. So I'm going to get up, probably set my alarm for like 3:30 or so, and I'm actually going to get up on my roof, and I'll bring the smartphone up there with the tripod, and see if I can see any of that launch. I have my doubts. I have my extreme doubts that I'm going to be able to see anything. I do have some mountains to my west that might block the view. What I'm actually sort of hoping is that I don't think I'm going to be able to see the first stage. Pretty sure I'm not going to be able to see the first stage. If I do, that'll be very, very cool. But I'm thinking that I might be able to see the second stage. Maybe. That's about, I think that's like, I want to say like 4 minutes after launch or so. So, yeah, as I said, I'll have my smartphone up there and I'll be watching the launch sort of live. And looking due west, really, really low. And if I see anything, I will definitely try to record it and put it on this channel. I've got my extreme doubts. I don't think I'm gonna see anything at all, but yeah, you never know. And it is sort of a unique opportunity. This thing is going all the way to Mars and stuff. Did you hear about the two um, uh, uh, um, CubeSats that are also going to Mars? I think this will be a first. They're called Marco A and Marco B, and I think their primary mission is to sort of be relay satellites. So they'll be able to the lander will be able to communicate with Marco A and or Marco B in real time and relay. Well, and then they'll of course relay that information back to Earth. So this is very, very cool, right? The lander doesn't have to point to Earth, right? It just has to point to one of these CubeSats, and then the CubeSats will send all that info to Earth, supposedly real time. So Yeah, could be kind of interesting. I think Marco has some other things that they're doing too. I'm trying to remember. But yeah, you know, look them up, Marco, uh, and yeah. So that's kind of interesting. That we're going to have some CubeSats flung at Mars, and it, they're basically just going to do a flyby of Mars. They're not going to orbit. You know, they're not going to do anything. They're just going to zoom by, and at least the person who was talking about it there said, you know, a couple of months after the flyby, it's like, you know, they're done. So, you know, we humans just like to toss our trash anywhere we want. So that's what we're going to be doing there. Kind of an interesting orbit. Um, Orbit around the sun. Don't know if it'd be yeah, I mean, I assume that they would enter some kind of a solar orbit where um, uh, the aphelion, the furthest point from the sun, is Mars, and the perihelion, um, the closest point to the sun, is about the orbit of the Earth. Right? That's but yeah. So kind of cool, kind of cool. So yeah, um, if you're so inclined, 11:05 UTC tomorrow, the launch of Mars Insight. It's going to be going on top of an Atlas V, I believe. Um, so you know, Atlas V is extremely reliable. Extremely. I don't. Have they had any failures at all? I don't know. Don't remember any. So yeah. All right. Well, very cool. Let's do an object of the day, and let's choose from the NGC catalog, the new general catalog. As I said, this is primarily non-stellar objects. So that means galaxies, um, planetary nebulae, gaseous nebulae, um, open clusters, and globular clusters. Now, some of the NGC objects are misidentified, and they're actually stars. We came across one of those a couple of weeks ago. Um, Excuse me, I forget which one it was now. But yeah, it's an NGC object that turns out to be a star. It was just misidentified. You know, thought it was a galaxy. You know, looking at these images, the NGC catalog was established, um, uh, I think, probably either, you know, visually, right, looking through a telescope, or through a survey that was called the Palomar Sky Survey, which was done, I want to say back in the 60s and the 70s or so. It was one of the big, one of the first big sort of all sky surveys. They photographed on photographic plates on glass plates with red filters and blue filters, and you know, that was as exciting in those days as Gaia is now. It's like, oh my God, we have this this um, this catalog, right? Because what you could do is you could take those glass plates, um, put them uh, um, on a machine, and measure, you know, the positions and the brightnesses of all the stars, right? And you know, not computerized or anything, or not very much. At least it was very manual, even for the 70s. I think these were done in the 70s. Um, so uh, So yeah, some of the NGC objects are misidentified, but let's go over. I'm going to share my screen and share. Here we go. And there's my Discord server, by the way. I posted a paper about breakthrough star shot that looks pretty interesting. It's pretty heavy. It's pretty heavy in the math, but take a look at that. Take a look at that. Um, anyway, I'm not going to be distracted by that. Let's go over to random.org, and I'm going to check my Pamela go. Yeah. I think for the InSight launch, they are expecting fog, so nobody's actually going to see the rocket jump off the launching pad, except for the cameras that are sort of close, and maybe even not even that, right? Depending on how thick the fog is, and it sort of sounds like they're going to ignore all the fog because it's not that big of a deal. It probably can be a big deal, but I don't think it's going to be. So even in thick fog where you can't see the rocket at all, they'll still launch. That's fog isn't a problem. But as soon as it sort of rises above the fog bank, which they said was going to be like 600 feet or so, if you're standing back um, a little ways, and there you'll see it. You'll see it. It's going to be nice and clear. So yeah, but I'm quite a long ways away from Vandenberg. So and from the West Coast in general. Although there was this that remember that SpaceX launch a couple of months ago that went over Disneyland and got lots of people excited. Apparently, people saw that from here. So if they can see that, then there's a possibility. All right, but I'm not going to get distracted by that. Let's go over and so there are 7,840 NGC objects, and they're ordered by right ascension. So sort of the east-west, sort of the longitude in the sky. So let's see. Let's do a drum roll here. Boink. All right. So NGC 3940 is the object of the day. So I like to go over to Simbad, which is a awesome astronomical database. Forget Wikipedia and all that. If you want to find out the real deal on an object, go over to Simbad. That's the place. That's the place to go. Now, of course, I already remember or forgot what the number was. So 3940, NGC 3940. 3940 places it pretty close to, that's right in the sort of in the middle, right? If there's 7840, 3940, so that's going to put it at a right ascension of around 12 hours or so. And most of the NGC objects at that right ascension is going to be galaxy land. So my guess, moderately educated guess, is that this is going to be a galaxy. And, most of the NGC objects are actually galaxies. So let's find out. Maybe we'll get a pleasant surprise. Hopefully, I love surprises. It's a galaxy. So it looks like it's an elliptical galaxy. That's what that E stands for there. And yeah, you see it has a right ascension of 11 hours, 52 minutes, 46 seconds, and a declination of 20 degrees positive, 59 minutes, 21 seconds. So yeah, it's pretty much, wow, that That puts it right in Virgo, I think. Oh, okay, it's in Leo. All right, very, very cool. Thank you, Uncle Bill. He's beating me to it because he's looking it all up and cheating. So this is an elliptical galaxy, which more or less means that there just isn't any dust, right? It's just all stars. There's no dust. There's no spiral arms. There's nothing. There's just stars. So, and of course, an elliptical galaxy has an elliptical shape. So, as you can see here, it's in the shape of a ellipsoid. So its major axis is like 1.2 arc minutes across, something like that, I guess. You can see that the center of this is overexposed, right? These images are taken from the Digital Sky Survey, probably the Sloan Digital Sky Survey, SDSS. Actually, is this 2MASS? Now this is the DSS itself. Let's look at the Sloan Digital Sky Survey instead. So yeah, you can sort of see that it's very elliptical, very, very sort of roundish, an ellipsoid. Um, so these are the magnitudes. The B magnitude is sort of a visible magnitude. So this is how bright it would appear to us to our own eyes. And I can say that magnitude 14.3 is pretty darn faint, right? We can see down, I mean, with the darkest skies, we can see down to about sixth magnitude with our own eyes. So, and in the case of astronomy, the larger the number, the fainter the object is. So, 14.3 is what, like 8.3 magnitudes fainter than what we can see, and every magnitude is a factor of 2.5, right? So what is that? 2.5 to 8.3, so 2.5 exponent 8.3. So that's like 2,000 times fainter than what we can see with our own eyes. So we're definitely not going to be able to just look up in the sky and see this. You need a pretty big scope. Um, I would say at least a 14-inch scope, maybe a 16 or a 20. You're not going to see this with an 8-inch scope. Now, if you photograph it, right, if you have some kind of a camera or some kind of a CCD, then you can do a long exposure, right? If you're able to track and guide, then you can do a long exposure. And so then you can use a smaller scope. Um, a good 10-minute exposure with a 6-inch scope, you'll see this galaxy, right? Now, it's not going to look like that, right? It's not going to look like that. You're going to see, sort of this inner area, maybe here. So if you were doing this by eye, right, using like a 20-inch scope, you're going to see this bright area here. You're not going to see all this fluff. This fluff is really faint, really, really faint. This magnitude is sort of the combined magnitude. So these other um, filters here, J, H, and K, lean more towards the infrared. And as you can see, this galaxy is brighter um, in the infrared, which sort of implies that there are a lot of red stars. And yeah, I think that's sort of the understanding, is that elliptical galaxies, for the most part, host older stars. These are older galaxies. That's sort of the conclusion that you can sort of jump to. Now that's a leap, right? I mean, we really, really, really don't know, but we look around and we start seeing patterns, and it's like, okay, this agrees with this, and this agrees with this, and this agrees with this. So after a while, it's sort of like if you throw a ball up in the air, you know, a million times, and it always comes down, you're sort of like, you know what? I'll betcha that when I throw this ball up in the air, it's going to come down. So, you know, sometimes you can be really, really sure, and sometimes you can't be. I always lean towards, well, we're never exactly sure, but yeah, we can be pretty darn sure. So let's see. These are the other names for this galaxy, and again, you know, these are usually just different catalogs. So, you know, a group of researchers have said, okay, let's look for all objects that have, um, you know, characteristics A, B, and C. And if they find an object that has those characteristics, then it goes into their catalog and it gets named. So that's why it has all these different names. And, you know, these names aren't as weird and confusing as um, most people think they are. If you sort of parse it out here, right? So here's the Cairns number, okay, J115246 dot 55 plus 205920.4. Okay. Well, it's all those numbers are is the right ascension and declination of the object, right? It's 11 hours, 52 minutes, 46.55 seconds, positive 20 degrees, 59 minutes, 20.4 seconds. There's nothing confusing there. That is as good a name as any because it provides you with information. You just have to read it, and you know exactly down to the tenth, down to the tenth of an arc second where this object is in the sky, and that's useful, right? That's useful. And as you can see, they all sort of have the same basic um, designation. Um, Not all of them are the same, right? Not all of them are exactly the same. See, this says 4655, this says 4641, and this says 20.4, this says 21.7. So there's slight differences. Well, why is that? I don't know. You're going to have to look it up. You're watching a movie. Cool. I might watch a movie later tonight. I might watch. I've had. I'm. Uh, uh, I I haven't watched um, the original um, Charlie and the Chocolate Factory in quite a while. You know, the one um, from back in the '70s with Gene Wilder. Yeah, yeah. Um, great movie. Um, I tried to watch the more modern one with Johnny Depp, and I never made I never made it through. I couldn't stand it. It drove me insane. It was terrible, at least in my opinion. All right, let's get back to NGC 3940. 3940, is that what it is? Yeah, 3940. It's been studied a little bit. Studied a little bit. We'll come back to that. Let's see how far away we think this sucker is. Okay, pretty far. So 90. There's pretty good agreement here, right? 92.4, 95.13. Let's sort of take the average of that. What is that? Maybe about 90, 93 and a half. So that's 93 and a half million parsecs. That's what that MPC is, megaparsecs. And wow, 120 kilometers an hour wind gusts. Well, hold on to your hat, man. Gee whiz. Okay, so of course, you know, every good scientist has a calculator within arm's reach. And being a good scientist, I have it in my hand right now. So I'm gonna do 93.5. Well, wait. let's do a megaparsec first. So a parsec is 3.26 light years, and a megaparsec, of course, is a million of those. So 3.26 times 10 to the sixth. Okay, that's how many light years. And then I'm going to multiply that by 93.5. So wow. So this galaxy is almost 305 million light years away. So that seems pretty far, and it is. It is. But it's still, yeah, that's still relatively sort of in the neighborhood, right? I mean, things don't really get far away until you're talking about like a billion light years, right? 2 billion light years, 3 billion light years. That's getting pretty far. The fact that this is 305 million, I'm not denying that that's not incredibly far, but as far as galaxy distances go, eh, pretty average, pretty average. But as you can see, its velocity, its radial velocity, and that's just how fast, um, relatively speaking, we and it are moving away from one another. Um, this is a pretty good clip, right? 6,500 kilometers per second. That's some pretty serious motion there, right? So yeah, we are moving away from it, or it is moving away from us at like 6,500 um, kilometers per second. So that's some pretty serious motion, I would definitely say. Doesn't look like there's any other observations or anything like that. So let's look at the picture. Love looking at pictures. I'm going to go back to the Sloan Digital Sky Survey here and then open that up. Yeah, I figured that this was probably part of Virgo. There's literally millions of galaxies in this area of the sky. And so as I zoom out, now this guy's pretty big. He's pretty big. But you can see here's one here. Now probably these smaller guys like this one. Wow, there's a whole bunch in here, right? Anyway, this one. These are probably galaxies behind this one. So this one's probably in the foreground, while every other galaxy here is probably, now this is just a guess, right? Can't be sure unless we actually go and measure it. But it actually looks like to me that there's a cluster of galaxies way behind this one, right? I'm seeing a cluster here of similar size, similar brightness galaxies. Let's zoom in a little bit here. Yeah, way out there. So this guy, I would say, this galaxy, NGC 3940, is probably in our foreground, in front of these guys, and I dare say it's probably blocking a couple of them too. That might be one. This is obviously a foreground star, so this sort of these these images sort of give us maybe, at least they give me sort of a sense of depth, right? So these stars, right? Star. Most of these are stars. Anything that looks sort of fuzzy and elongated probably isn't a star, but that's probably a star. That's probably a star. These are all stars in our galaxy, right? So these are the closest things to us when we're looking in this direction, right? These are inside of our galaxy. We're sort of looking through our galaxy, right? And we're looking through our galaxy to this galaxy, right? But then this galaxy is, whoop, what did I do? This galaxy is a foreground object to these galaxies back here, right? So very cool. Here's another one over here. Sort of looks like, I don't know what kind of galaxy you would call that. It doesn't look like a spiral, but look at how bright the center is compared to the outside. So, interesting. Here's some edge on, probably spirals here. So let's zoom out a little bit more, because the more and more we zoom out, yeah, okay, so here's a pretty big galaxy. Now you can see this galaxy and NGC 3940 look about the same size, about the same brightness. So I'm gonna take a big risk here and say that I'll bet you that these two galaxies are probably about the same distance from us, and probably associated with one another in some way. This one too, maybe, just given how bright it is, right? If you sort of assume that all these galaxies sort of have the same intrinsic brightness, then the fact they're looking about the same apparent brightness probably means they're all about the same distance away. That's sort of a really rough, educated guess. But wow, there's lots of galaxies. Here's a galaxy. Here's a little spiral galaxy here. Let's take a look at that one a little bit. So I would say that these are all sort of behind 3940, but we're seeing some structure here, right? Some definite spiral structure, spiral arms. Yeah, very cool. And wow, lots of galaxies here. Lots of galaxies. Here's a galaxy. There's a galaxy. Wow, look at these guys. This is a cluster of galaxies. Very cool. You can usually distinguish stars because you can see these diffraction spikes. These diffraction spikes are caused by the telescope themselves. Something has to be holding what's called a secondary mirror, and so there is diffraction along the structure that sort of holds the optics in place. And so these are basically just reflections off of the optical path. So you can usually tell the difference between a star and a galaxy, right? Because a galaxy, you're not going to see those spikes like you do here. You usually only see a spike if you're looking at a point source. And a galaxy, an extended galaxy like this, is definitely not a point source, right? Let's sort of scan around. Wow, this is like galaxy heaven. If you like galaxies, woo, there's a pretty one. There's a pretty spiral right there. Looks like a barred spiral. Ooh, isn't that nice? So there's a center and then there's a bar, right? And that's why it's called a barred spiral, because it has a bar and then it's got these arms. And, this side is different from this side, and it's hard to tell if these structures are inside or outside of the galaxy, maybe behind, maybe in front. Too hard to tell. Pretty though. Nice color. But yeah, lots of galaxies here. Woohoo! There's another bright star. You can sort of see there's a red star, sort of a yellowish star. Here's a blue star. Here's another red star over here. Now I'm completely lost. Is this one our target? I don't remember now. I don't think so. Yeah. It is. It is. All right. Well, cool. So there's that guy. Now the last thing I like to do is I like to look at the papers, because the papers sometimes tell us interesting things about these objects. Now, this isn't a very well studied object, right? Not much, but let's take a look here. See if there's anything interesting. Where are compact groups in the local universe? Galaxy groups. So it's obviously, it seems like it's part of a galaxy group. Red channel, 6,000 to 8,000 angstrom nuclear spectra of 376 local galaxies. See, they're calling this a local galaxy, right? 308, 305 million light years away is local. Redshift survey. So maybe it's an AGN, that stands for active galactic nuclei. So maybe this galaxy is a little bit more active. Oh yeah, yeah. Looking, even using a small scope at a dark site, if you look in the Virgo area, you will see more galaxies than stars. Yeah, for sure. Unitating old stellar systems from globular clusters to giant ellipticals, groups of galaxies of the 2-micron all-sky redshift survey. That's 2MASS. New catalog of ISM content in normal galaxies. Identification and designation of galaxies. Cluster and infall region nearby survey. So there's the cairns. Talked about the cairns name a little while ago. Group catalog. Surface photometry of galaxies. Surface photometry. Streaming motions of galaxy clusters within 12,000 kilometers per second. Arcsecond positions of UGC catalogs or galaxies. Universality and fundamental plane of E and S0 galaxies. Sample definition of I and I band photometric data. Is this Abell 1367? Doesn't look like it. Well, anything too incredibly interesting there? Seems to be not an incredibly exciting galaxy. I mean, every one of these are unique and interesting in their own way, but I'm not really seeing anything incredibly interesting. Let's just observations of 588 galaxies with the Turgo 1.5 meter telescope. Let's just look at this really quick, see what it has to say. So they're looking at these galaxies in the near infrared, the H band, as they say. So let's see if there's an actual paper here. Should be. Yay. I encourage all of you to check out archive.org. I'm going to say this over and over and over again 1 trillion times. It's awesome, not only for all things astronomical, but science, mathematics, economics, computer science. It's the latest and greatest. It's the bleeding edge. It's where all the new papers are published. Anyway, this is an older one. This is from 1999. But let's see what it shows here. Taking you along. That's what this live stream is all about. We go along a little journey of discovery for ourselves. I'm not here to teach you anything. I'm here to learn with you. Let's see. So we present near-infrared H-band surface photometry of 558 galaxies in the Coma supercluster in the Virgo cluster. Yep. This data set obtained by that camera mounted on the Okay, so let's just go for it here. Now it was 3940, right? Yeah. Let's just see if they reference 3940. 3940. Oh, I don't see it. I got the ding of no. So, well, let's see what else is here. I'm going to zoom out one thing here because that's a little too big. They've got everything double spaced. It's kind of interesting. How many authors do we have here, and where are they from? Okay, they're all European, Italy, Germany, France. Cool. Astronomers from around Europe. It's always nice to see, collaborations and whatnot. Report on near-infrared H-band observations of 558 optically selected galaxies. For the most part, 457 are of early type, they call morphology, found in the regions of the Coma supercluster. According to these guys, they lie within 5,000 and 8,000 kilometers per second. And yeah, I think this one was around 6,500 kilometers per second. Remember right? Early type galaxies brighter than photographic magnitude of 14. The observations were done at a 1.5 meter telescope f20. Wow, so that's a very, very long focal length. Don't know anything about Turgo at all. I wonder if it's still operational. Let's just find out really, really quick. Probably is. TIRGO telescope. Looks like it still is. It's located in the northern tower of the, I'm not going to even try to pronounce any of this. It was a 1.5 meter Cassegrain telescope with a tip tilt correcting secondary and optimized for infrared observations, but was decommissioned in March 2005. The telescope and related instrumentation were run. Oh man, you know what? This is, you know, this is just absolutely ridiculous. A one, if you're not going to use, if you have no use for a 1.5 meter telescope, look, I will give you my address, okay, and you can just send it over here, okay. Oh, that's awful. That's awful. Probably it's mothballed. Probably it's still there, and it's just sitting there doing nothing at all. It's at 10,000 feet in the Swiss Alps, maybe, and it's just sitting there doing nothing. That's awful. Okay, so this telescope isn't used anymore. So they had 32 nights. That's pretty good. They lost 10 nights, probably because of clouds and stuff. So half of the nights were photometric, which means the quality of the data was high. Yeah, the seeing ranged between 1.5 and 3.5 arc seconds. So that's not bad. That's not bad. Anything more than 3.5, you're starting to get pretty funky. Yeah, okay. So there there's their seeing profile there. So yeah, this is just describing how they collected their data. Photometric calibration. So in order to calibrate, they looked at these so-called standard stars, where they know exactly what the magnitude is, and then they can measure the magnitudes of their stars and sort of say, okay, well, our star is uh, um, this much brighter or this much fainter than the standard star, and they can calibrate that way. Sending the telescope. Let's see. So doing their flat fields was tricky. They take their flat fields from the sky itself. So that's a tricky proposition, because you got those pesky stars in the way. But it can be done. It can be done. Okay, so here is the program galaxy, a one-page example. Yeah, if you want the whole thing, we can get it if we want. And of course, my guess is that would be our object NGC 3940 would be on that list. But yeah, so they're just measuring various parameters, the position, the magnitude. It looks like the major axis and the minor axis in arc minutes. So yeah, a lot of these are elliptical in shape. Here's a big one, right? 3.39 arc minutes by 1.07 arc minutes. We're calling it an S0 galaxy. But a lot of these are ellipticals and S0s. All right, so that's that. Let's sort of see so pretty dark sky, right? They're getting maybe a 21st magnitude sky. That's not bad. Aperture photometry. That's the standard way to do photometric measurements. That's exactly what I do too. Yeah, I think we're running a little bit long here, so I'm going to. What am I going to show you? Data I collected last night. I can show you that over the weekend. Is not incredibly interesting to look at, but I will definitely show you at least the images I took. It's just binary star, so just two stars. Um, the analysis of the data will take a little bit longer. So mainly because it's just tedious, and um, yeah, I just have to sit down and do it. So, but Bobby, I definitely will. I definitely will. For you, I will. I'll show you everything. I'll show you the flats. I'll show you the darks. I'll show you the data. Let's see. Distribution, low surface brightness. Yeah, it's just, this is just a regular old standard survey paper saying, that we measured these things. Here they are. These are, this is how we collected the data. This is how we um, uh, um, did the calibrations. This is how we made our measurements, and here are the results. And that's about it. That's about it. The cool thing is of course all of the references and stuff, because references are sort of like going back into history and you know, learning more about all of this. So you know, these references are awesome, very very awesome. All right, well, cool. I think that it is about time to get out of here for today. So I'm going to stop sharing that. I'm going to pop back over here, and yeah, I think we're about done. We're over an hour, and I like to keep these to, you know, around an hour or so. Sometimes a little bit more, sometimes a little bit less. Don't want to go too long. You know, I greatly respect all of your time. Glad you come in. Feel free to come in anytime you want. That's one of the cool things about a daily live stream is that if you want to come in every day, come on in. If you want to come in every week, come on in. It's whenever you decide. The only one obligated is this guy right here, and I'm having a blast. So yeah. This is easy, it's fun, and I get to share a passion. So, all right, enough with the passion. I'm going to get out of here. Peace, cheers, have a great spin, and I will see you tomorrow. Same time, same place, 2 hours UTC. Hit the thumbs up, hit the thumbs down. Reaction is all I'm interested in. Make some comments, subscribe if you haven't already, share this around if you know others who have a similar passion. um, let's bring them in. I'm looking for my core, right? I'm looking for my core group, and I've got a worldwide audience, so there's a lot there. This can probably be a pretty big core group. I think there's at least 100. We just have to find them. Which is a little bit of patience, a little bit of persistence, and you know, word will spread. Word will spread, and as I get better and better and better at this, yeah, I think it can only get better. So, all right, I'm gonna get out of here. Peace, cheers, and all that. Take care. See you tomorrow. Bye.